Hello, all the IGCSE students. I welcome to all of you to this class where we are going to discuss extraction of iron from hematite. So let's first discuss that what is this hematite? So hematite is an important ore of iron. Now, when we say ore, what does it mean? So ore is that rock which is rich in metal. Do we know, dear students, that we need to dig the earth crust to take out some minerals, some rocks from the earth crust to get metals like iron. So ore is nothing but it is the rock which we have extracted from the earth crust and it is really rich in metals. And let me show you how hematite, which is the ore of iron, looks like when we take it out from the earth crust. It looks something like this. Yes, it doesn't seem to be pure iron. Definitely not. It has some impurities associated with it. Now, when we talk about extraction of iron from hematite, we mean that how will we obtain pure iron from this ore, which is hematite? So let's have a look. We should also know the chemical formula of this important ore of iron. The formula of hematite is Fe2O3, which means it is iron 3 oxide, where the oxidation state of iron is +3. Let's have a look on the setup which is used to extract iron from hematite. So we have this big kind of setup which is actually called a blast furnace. We use this to extract pure iron from the ore which is hematite, and that we just discussed is actually Fe2O3. Let's have a look on this big setup. It is called blast furnace because it is very hot. It reaches a temperature greater than the melting point of iron, and that is why we obtain iron as molten form. You can see here, this setup is giving us iron in the molten form. Now, dear children, let's have a look on the openings given in this setup. I would like you to have a look on this opening here, which is for the hot air to go in, this and this. Dear children, we we let the hot air go inside. Now, this hot air majorly contains O2 and N2 because it's just atmospheric air. So we heat this air a lot and we push it in the system. The second opening I want you to see is this here at the top, this opening here. Now, this opening is actually an opening for charge. Now, what is this charge? So, dear children, charge is actually the mixture of this hematite, which is Fe2O3, and we add some other things to it also. One of the things we add is carbon, which is called coke. Coke is one of the pure forms of carbon. So we add coke, which is chemically written as C, and we also add calcium carbonate to it. Now, Fe2O3 is something from which we are aiming to extract iron. Carbon is used for specific purpose. It acts as a reducing agent. I'll tell you how. And calcium carbonate is used to remove sand impurities associated with hematite. Let's get started. Now, this furnace works at 3 different temperatures. We have 3 different levels shown here in the setup. So I'll be talking first about this setup below, like this part of the setup. So at this setup, what happens is carbon, which is coming from the top here, you see, it's filled in, the charge is filled in from the top here and it's flowing down, right? So the carbon coming from the top reacts with oxygen, which is coming from the down. As we discussed this here, this opening is for the hot airs to go in. And the product of their reaction is CO2, gaseous. Now moving to the top at this level, we have another reaction happening. See, this CO2 gas rises at the top. It goes to the top. So CO2 rises from here to here. It's going there. Now this CO2, which is a gas, it reacts again with some of the coke coming from the top, the carbon. And the product we get in this case right now is CO. We all know CO is carbon monoxide. It's a really poisonous gas. But yes, this needs to be formed in this setup. Now the third reaction happens at this level of the setup. And here what happens is the actual super important reaction where the hematite, which is iron oxide solid, reacts with this carbon monoxide gas. And what it forms is, it forms liquid iron, and CO2 gas is emitted out. Now, dear children, see, we have got the desired product. We were supposed to get iron, pure iron, and we have got it. Now, you might be wondering that why are these openings given here? This opening and this opening here. So as it is mentioned that these openings are for the waste gases going out. Now, what are the waste gases they are talking about? It's clearly seen that now we have obtained iron. So CO2 can be considered as a waste gas, and it is actually in this region now. So this CO2 will flow up and it will go out from these openings. Now, not only CO2, dear children, in fact, N2, which was present in the gas, will also remain as it is. And the waste gases which are going to be emitted out are the waste gases emitted out are N2 as well as O2. No, sorry, CO2. Yeah. Both of these gases are going to emit out from these openings given, right? So this is what happens in the blast furnace. Now, one of the important things, the use of CaCO3. We have understood the use of iron oxide. It's used to obtain iron. The use of carbon, which is coke, is that it acts as a reducing agent in the system. How it acts as a reducing agent is you see that this CO present here reacting in this reaction is actually doing what? This CO is helping iron oxide to get reduced. See, iron is losing oxygen and getting converted to iron. So iron oxide is getting reduced with the help of CO. So CO is the reducing agent here. And how has CO been formed? CO is formed with the help of this coke supplied through charge. So yes, carbon acts as a reducing agent in the form of CO. Now use of calcium carbonate. So as we discussed that calcium carbonate is used to remove sand impurities. Now what happens is because of the high temperature in the blast furnace, calcium carbonate in this presence of heat decomposes to give calcium oxide and carbon dioxide gas. Now this calcium oxide starts reacting with the sand impurities present in the hematite. Now, sand impurities have the formula SiO2. Yes, it is silicon dioxide. And why is it so? Because sand mainly contains this as impurity. So this is sand impurity, or we can call it silica, or we can even call it silicon dioxide. Now, when CaO reacts with SiO2, what it gives is calcium silicate. Calcium silicate is the impurity. CaSiO3 is the formula. It's also in its liquid state. And this is the compound called calcium silicate. Yes. So dear children, you see we have been given these openings here at the bottom. This opening is for molten slag. Now, what is this slag? The slag is nothing but this molten impurity we just talked about here. So this is nothing but slag. Now, there is one good thing to observe here, and that is this slag is obtained above the iron, above the molten iron. What does this tell us about its density? Yes, it definitely tells us that the slag is lighter than iron, right? Yes, we know iron as a metal has a high density. Now, dear children, this is all about the extraction of iron from hematite. I hope you have enjoyed it. Thank you very much for being with me.